In this problem, we have to show that 1 plus omega raised to the power of n plus omega raised to the power of 2n. It is going to have two values, a value of 3. If n is a multiple of 3, here n is actually a natural number, and 0 if n is not a multiple of 3. And it's also provided that 1 omega and omega square are cube roots of unity. So since they are the cube roots of unity, it immediately follows that the sum of the roots 1 plus omega squared will be 0, and the product of the roots will be equals to 1. We'll use this fact. Now, coming to a problem, now let's consider case number 1. So let's say our n is a natural number, and also it's a multiple of 3. So since it's a multiple of 3, so we will consider n to be equals to 3 times k, where k is also a natural number. Now that's evident from the fact that if n is a natural number, then k must be a natural number as well. Let's substitute this into our given expression. So we have 1 plus omega raised to the power of n plus omega raised to the power of 2n. So this will be 1 plus omega raised to the power of 3k plus omega raised to the power of, so we have 2 times 3k, so that becomes 6k. So this is 1 plus omega raised to the power of 3 whole raised to the power of k plus omega cubed whole raised to the power of 2k. Now omega cubed, that value is equals to 1. So we have 1 plus 1 raised to the power of k plus 1 raised to the power of 2k. So this is simply 1 plus 1 or 3. So that means whenever our n is a multiple of 3, we're getting a value of 3. So this proves the first part. Then we'll take case number 2. Now case number 2, here n is not a multiple of 3. So since n is not a multiple of 3, so we can take n to be equals to 3k plus 1. So there are other possibilities as well. For example, we can take n to be equals to 3k plus 2. Then we can take n equals to 3k minus 1, or n equals to 3k plus 5. But what we'll do, we'll only use this one particular case, and if you want, you can check those other cases as well, but it will be true nonetheless. Now, let's use this particular situation. So we have 1 plus omega raised to the power of n plus omega raised to the power of 2n. So this will become 1 plus omega raised to the power of 3k plus 1 plus omega raised to the power of 2 times 3k plus 1, which is equals to 1 plus omega raised to the power of, so 3k plus 1 can be also expressed as omega raised to the power of 3k times omega. And we have omega raised to the power of 6k plus 2, which is equals to 1 plus omega raised to the power of 3k times omega plus omega raised to the power of 6k times omega squared, which is 1 plus omega cube whole raised to the power of k times omega plus omega cube raised to the power of 2k times omega squared. This is 3. Now omega cube, that value is equals to 1. So we have 1 plus omega squared, and we know that this value, the sum of the cube roots of unity equals 0. So this value will be equals to 0. So that means when n is not a multiple of 3, in that case, the value of this particular expression is going to be equals to 0.